Have you ever really thought about running JavaScript somewhere other than your web browser?
Right.
I mean, most of us, we immediately think JavaScript. We think websites, making pages interactive,
Yeah.
animations, that kind of thing.
That's the standard association, definitely.
But what if you could take that same language, JavaScript, and use it to build really powerful, scalable stuff on the server side?
Yeah.
Handling data, building APIs, all that back-end magic.
It's a huge shift, isn't it? It takes JavaScript from just being for the front end, the client side, and turns it into a full stack contender capable of way more than people often assume.
Exactly, and that's precisely what we're diving into today, this deep dive. It's your shortcut, basically, to getting the core ideas behind Node.js.
Mhm.
Because it's not just another framework,
Yeah.
right? It's this powerful runtime environment built specifically for making things like real-time apps, things that handle tons of data and scale up really well on the server.
And our goal here is to really equip you with those fundamental concepts. We want to, pull back the curtain a bit on its unique way of working, its architecture.
Show off its built-in tools.
Exactly, the built-in tools, and crucially, how it handles asynchronous operations. That's what makes it so incredibly efficient for what the web demands today.
Okay, so let's kick things off then. The big question. What is Node.js, really, at its heart?
Well, think of it as a special place, an environment where JavaScript can run outside the browser. It's built on Google Chrome's V8 engine.
Ah, the V8 engine. So the same super fast engine that makes Chrome snappy?
The very same one. But here, instead of drawing buttons and pages, it's executing your server logic, reading files, talking to databases, handling network requests.
Gotcha. And what makes it tick? What are the defining features we need to grasp?
Okay, the really key things are, first, it's got a single-threaded architecture, one main thread handling everything.
One thread. That sounds potentially slow,
Mm.
like a bottleneck.
It sounds like it could be, but here's the clever part. It's paired with an event-driven model. It uses events and callbacks to manage what needs doing, and critically, it uses non-blocking I/O.
Non-blocking I/O. Okay, let's unpack that. You've got single-threaded, which sounds like waiting in line, but then non-blocking, which sounds like skipping the line. How does that actually work together? It seems contradictory.
It does seem like magic, but it's all down to something called the event loop. That's the absolute core mechanism behind this non-blocking behavior.
Loop.
It's how that one thread can juggle, essentially, tons of operations at once without getting stuck waiting for any single slow one. Imagine you ask it to do two things, one quick calculation and one slow database query.
Okay.
With non-blocking I/O, Node doesn't just sit there waiting for the database. It sends off the request to the database, says, hey, let me know when you're done, and attaches a callback function for that. Then, crucially, it immediately moves on to the next task, maybe that quick calculation.
Okay, so it's like a really efficient waiter in a super busy restaurant.
Yeah, that's a perfect analogy.
They take your order, give it to the kitchen, the slow part, but they don't just stand there watching the chef cook,
Yeah.
right? They immediately go take another table's order.
Exactly. The kitchen, the database, the file system does the heavy lifting in the background. That work is offloaded. Meanwhile, our single Node.js thread, the waiter, is free to handle other requests, other customers.
That makes sense. Is there a code example that really shows this off?
Oh, absolutely. The classic one is using set timeout with a delay of 0 milliseconds. Let's look at this.
JavaScript.console.log, start, set timeout, console.log,
Yeah.
end. Okay, so looking at that, my first instinct,
There.
especially with that zero delay, would be start, then timeout, then end. Seems logical.
It does seem logical, but that's not what happens. What you'll actually see printed is start, then end, and then timeout.
Whoa, okay, why?
That's the event loop in action. It always runs the synchronous code first. So console.log start runs.
Right.
Then console.log end runs. The set timeout call, even though the delay is 0, registers an asynchronous operation. It tells Node, hey, run this callback function, but do it later. So the callback gets put onto a separate queue, the event queue.
A queue.
Yes. And the event loop only checks that queue and runs things from it after the main thread has finished all its current synchronous work and is basically idle, twiddling its thumbs.
So even a 0 millisecond delay means do this after everything else currently running is finished.
Precisely. It's not about the time delay itself, it's about deferring it off the main execution path.
Okay, so what does this actually mean for you, the listener, when you're building something? What's the practical impact?
It means you can build applications that feel incredibly fast and responsive because they aren't getting stuck waiting for slow things like reading a big file or making a network call or waiting for database query.
Right, the I/O operations.
Yeah. Exactly. Input-output. Node doesn't wait. It registers the callback and moves on. This is huge for resource efficiency, too. Think about a chat app with thousands of users. A traditional server might need a whole thread for each user, which eats memory fast.
Yeah, that wouldn't scale well.
Not at all. But Node, with its event loop, can handle massive numbers of connections with far fewer resources because that single thread isn't blocked. It just keeps processing events as they complete. That's the real game changer, especially for anything I/O heavy. Streaming, APIs, real-time data.
That efficiency point is really key. Okay, so Node isn't just fast, it's smart about how it uses resources. Now let's talk about the tools it gives you. You mentioned built-in modules, like a starter toolkit.
Exactly. Node comes with a set of core modules built right in. You don't need to install them separately. They're fundamental for interacting with the system.
Like the Fs module, or file system stuff.
Perfect example. Fs lets your JavaScript read files. fs.read file. Write files. fs.write file. Delete files. fs.unlink. Check if they exist. Basically, anything you need to do with the file system on the server. Stuff you just can't do from browser JavaScript for security reasons.
Makes sense. And for web stuff, there's HTTP.
Absolutely fundamental. The HTTP module lets you create basic HTTP servers really easily. You use http.createServer to say, okay, when a request comes in, do this. Maybe send back a simple hello from Node.js. It's the absolute foundation for building web servers or REST APIs.
And dealing with file paths can be messy, especially across Windows and Mac or Linux.
Oh, definitely. That's where the path module comes in. It's a lifesaver. You use things like path.join to build paths correctly, regardless of the operating system. So path.join, dir name, images, logo.png will always work using the right slashes automatically. No more manual path juggling.
Nice. What about getting info about the system itself?
For that, you've got the OS module. Need to know if you're running on Win32 or Linux.os.platform. Need to check how much free memory the server has. .os.frame. It gives you direct access to operating system information.
Very useful. And URLs, web addresses.
Yep, the URL module is great for that. You can take a full URL string, parse it into its components, the protocol, the host, the path, the query parameters. Like if you have .search node in page 2, you can easily grab node in 2. Really handy for routing requests or processing user input from the URL.
And finally, one that sounds really important, crypto.
Hugely important for anything involving security. The crypto module provides tools for encryption, decryption, and hashing. You absolutely need this for things like securely storing user passwords. You'd hash them using something strong like SHA-256 from this module, or generating secure random tokens for things like password resets or session management.
Right, so you never store passwords as plain text. You store the hash.
Never plain text, always hash them. Crypto gives you the standard, robust tools to do that properly.
That crypto module, it always felt like where Node really shows its server-side strength. You're not just building websites, you're building secure systems.
You absolutely are. And what's really striking about all these modules, Fs, HTTP, Path, OS, crypto, is that they give JavaScript direct access to low-level system stuff. Things a browser just locks down.
Yeah.
That's the bridge. That's what makes Node.js such a capable server-side platform. It connects JavaScript to the underlying OS power.
It really does round out what JavaScript can do. Okay, beyond those core modules, there are also some global things and special tools for handling data efficiently, right?
Yeah.
Let's touch on those. Globals first, like dir name.
Right, dir name and file name. You'll see these everywhere. Dir name gives you the absolute path to the directory containing the current script file that's running.
Okay, the directory path.
And file name gives you the full path, including the file name itself. They're super reliable for figuring out where other files are relative to your script.
And then there's process. That sounds important.
It is. The process object is your connection to the currently running Node.js process. You can get environment variables from process.env, essential for configuration, like database passwords that change between development and production.
Well, like API keys and stuff.
Exactly. Or you can get command line arguments passed to your script using process.rgv. Useful for utility scripts.
Okay, now here's something I know trips people up sometimes. The difference between dir name and process.cwd. They sound similar.
They do, but they're crucially different. Dir name always points to the directory of the file being executed. Process.cwd, which means current working directory, tells you where you were in the terminal when you launched the Node process.
Ah, So if I'm in my main projects folder, but I run a script that's inside a util subfolder, process.cwd is the project folder, but dir name inside that script is the utils folder.
Exactly right. And that's why if you need to load a file that sits next to your script, you almost always want to use dir name to build the path. It's much more reliable than relying on where the user happened to launch the process from.
That's a really good aha moment. Thanks for clearing that up. Now let's talk about handling data efficiently, especially big data. Buffers and streams. What's a buffer?
Okay, so a buffer is basically a temporary holding spot for raw binary data. Just raw bytes. It's not like a JavaScript string, which deals with characters.
Binary data, like image data or network packets.
Precisely. When you're working with files directly or network communication, you're often dealing with raw bytes. Buffers let you manipulate that binary data directly. They're fixed-sized chunks of memory. You can create one from a string, like buffer.fromHello, see the raw bytes, and then convert it back using buff.to a string. It's low-level, but very performant for binary stuff.
Got it. Raw bytes and fixed chunks. And streams, how are they different?
If buffers are about holding chunks of data, streams are about moving data efficiently, usually in chunks, without needing to hold the entire thing in memory at once.
Okay. So this is key for large files.
Absolutely key. Imagine you have a massive video file, like gigabytes in size. You don't want to load that entire 10 GB file into your server's memory just to process it or send it somewhere. That would crash most servers.
Right. My laptop would probably just give up.
Exactly. Streams let you process that data piece by piece, chunk by chunk as it flows through. You read a small chunk, process it or send it, read the next chunk, and so on. It's incredibly memory efficient. Perfect for logs, audio, video, large uploads, downloads.
It's like drinking from a river through a straw, instead of trying to carry the whole river in a bucket.
That's a great way to put it. And Node has different types. Readable streams for reading data from a source, writable streams for writing data to a destination, duplex, both read and write like a network socket, and transform, which modify data as it passes through, like compressing it.
And you can connect them.
Yes, the classic pattern is using .pipe. You can take a readable stream, like reading a file, and pipe its output directly into a writable stream, like the HTTP response back to a user, readable.pipe, writable. Data flows through efficiently without you needing massive amounts of RAM.
Wow. Okay, so buffers for raw binary chunks, streams for efficiently moving data in chunks. These tools really show how Node is built for handling serious data and network tasks.
They are fundamental to its performance, especially under load.
Which brings us back beautifully to the heart of it all, asynchronous programming. We keep mentioning non-blocking I/O. Let's make sure we're crystal clear on synchronous versus asynchronous.
Right. Synchronous code is like reading a book page by page, line by line. You finish one line completely before starting the next.
Yeah.
If one line tells you to go wait somewhere for an hour, well, you stop reading the book for an hour. The whole process blocks.
Everything grinds to a halt.
Exactly. Asynchronous code is different. It performs tasks in the background. It kicks off a task, like that wait for an hour task, but doesn't wait. It immediately moves to the next line of the book. Later, when the background task finishes, it uses some mechanism like a callback or a promise or async await to let you know the result is ready.
And that not waiting is why it's so much faster for I/O, right?
Yeah.
Because reading files, hitting databases, calling APIs, those things take time.
Huge amounts of time, relatively speaking, compared to CPU speed. If your server waited synchronously for every database call for every user, it would become incredibly slow and unresponsive very quickly. Asynchronous lets it handle many things seemingly at once.
Okay. And how we write this async code has changed over time in JavaScript.
It really has. The original way was using callbacks. You'd pass a function into another function, and that inner function, the callback, would be executed when the async operation finished.
Right, like our setTimeout example earlier. Let's say we have a function fetch data that takes a second. JavaScript.function fetch data, setTimeout CB data fetch. CB is the callback. Fetch data console.log. Pass console.log is the callback.
That works. But if you need to do several async things one after another, fetch data, then process it, then save it, you end up nesting callbacks inside callbacks inside callbacks.
Ah, the infamous callback hell, or pyramid of doom. It gets hard to read fast.
Very hard. That's why promises were introduced. A promise is an object representing the eventual completion or failure of an asynchronous operation. They allow you to chain operations using then, much cleaner.
So that same fetch data could return a promise.javascript.const fetch data. You provide setTimeout fetch data.then console.log. Chain with then.
Exactly. Cleaner, easier to manage sequences and errors. And then came the latest evolution.
Async await.
Yeah.
Which feels almost magical the first time you see it.
It really does. Async await is basically syntactic sugar built on top of promises. It lets you write asynchronous code that looks almost exactly like synchronous code. You mark a function with async, and then inside it, you can use await before calling a function that returns a promise.
And the code just pauses there until the promise resolves without blocking the whole node process.
Precisely. It pauses the execution within that async function only, letting other code run, and then resumes when the awaited promise settles. And you can use standard try.catch blocks for error handling, which is much more intuitive than .catch chains sometimes.
So we have the fetch data with async await.
JavaScript, const fetch data. New promise, resolve done, 1000, async large, need an async function wrapper .try. Const data, await fetch data, look synchronous.console.log, data.catch, error.console.error, error fetching data.console, error fetching data.
Wow. Yeah. That await fetch data just looks like a normal function call.
Yeah.
Much easier to read.
Much easier. But it raises a critical point. Why is truly mastering these async patterns so vital for Node? It's not just about syntax.
Right. What's the deeper implication?
It's because Node's power comes from not blocking that single thread. If you misuse async patterns or accidentally write blocking code, maybe a really long calculation loop without await or yielding,
You freeze the event loop.
you freeze the whole thing. You completely kill Node's performance advantage. So understanding when to use await, when maybe not to await immediately to run things in parallel, and how the event loop interacts with promises and callbacks, that's where the real skill comes in for building robust, scalable Node apps. What about really heavy CPU work? That's a different challenge again, maybe needing worker threads.
That's a great point. It's about understanding the flow, not just the keywords. Okay, we've got the core concepts, the tools, the async nature. Let's try and piece some of this together. You mentioned the HTTP module for servers. Can we actually build a tiny one?
Absolutely. It's surprisingly simple. You use http.createServer, pass it a function to handle requests, and then tell the server to listen on a specific port, like 5000.
JavaScript.const http.create servers. res.writehead 200 content type res.writehead 200 content type res.end hello from Node.js n res.writehead 200 content type.server.listener 5000 server running at http.localhost.5000 console.log server running at http. So that code, when it runs, the server just starts listening on port 5000.
Yep, it sits there waiting. Then when a request comes in, like someone typing http.localhost port 5000 into their browser,
Node executes that function we gave create server, the one with rec and res.
Exactly. Rec is the incoming request object with details like the URL headers, and res is the response object you use to send stuff back. Here, we're setting the status code to 200, okay, saying the content is plain text, and then sending back the hello from Node.js string before closing the connection with res.end.
And I can actually go to localhost 5000 in my browser and see that text.
You absolutely can. Run that code, open your browser, and you'll see it. That's the foundation. From here, you can build APIs that return JSON, serve HTML files, route different URLs, anything a web server does. It's pretty cool seeing JavaScript do that directly.
It really is. And this understanding opens the door to some practical starter projects, doesn't it?
For sure. You could easily build on this.
Like maybe a simple command line tool. Use fs to read a file, and process.rgv to get the file name from the user when they run the script.
Perfect example. A CLI file reader. Combines fs and process, great practice.
Or maybe something slightly more web-focused, like serving actual HTML, CSS files.
Definitely. A static file server. That combines HTTP to handle requests, fs to read files from disk, maybe from a public folder, and path to figure out the correct file paths. If the request is for style.css, you read public style.css and send it back. If the file doesn't exist, you send a 404 not found error.
So you're basically building a mini version of what servers like Nginx or Apache do for static files.
You are. It's a fantastic way to solidify how these core modules work together.
Okay, so for everyone listening, what this all really means is you've now got a solid grasp of Node.js's foundations. You're not just hearing buzzwords. You're actually equipped to start building things.
You really are. You understand the unique architecture, single-threaded, event-driven, non-blocking I/O. You know about the essential tools like fs and HTTP. You've seen how Node handles data with buffers and streams. And crucially, you understand the importance and evolution of asynchronous programming up to async await.
Those are the pillars, right? Single thread, event loop, non-blocking I/O, core modules, async patterns. That's the toolkit for building powerful back-end apps.
Couldn't have said it better myself. Those are the absolute fundamentals.
And honestly, we've covered a lot, but it feels like we've also just scratched the surface. Understanding this stuff, though, it really sets you up for the next step, doesn't it? Like using frameworks like Express.js.
Absolutely. Frameworks like Express build on top of these core Node concepts. They don't replace them. They just provide helpful abstractions and structures, especially for building complex REST APIs much faster. Knowing the Node fundamentals makes learning and using those frameworks so much easier.
So here's something to think about as we wrap up. Now that you have this foundational understanding of Node.js, how it works under the hood, its async nature, its core tools, how might that change the way you think about building things for the web? Not just websites, but real-time systems, APIs, server-side logic.